Zosimus of Panopolis, one of the founders of alchemy in the Greco-Roman Egypt, claimed, "What makes every work perfect is cooking and grinding." The earliest alchemists knew how to extract mercury from cinnabar and how to produce artificial cinnabar. Grinding and heating were the two key actions of these chemical technologies, so that recipes for synthesizing cinnabar are preserved in Greek, Syriac, and Arabic alchemical treatises.
Our study offers a unique perspective of the origin of mechanochemistry and its enduring relevance in today's world. By drawing parallel between these ancient techniques and modern mechanochemistry, our article emphasizes the continuity of human innovation throughout history. It highlights how contemporary mechanochemistry builds upon these age-old practices, offering insight into the fundamental principle governing chemical transformation induced by mechanical action.
We focus our attention on the synthesis of cinnabar, a red pigment containing mercury sulfide. We started by replicating the well-known reaction between sulfur with mercury, which was described as a two-step procedure. The first step consisted in the grinding of the reagent, which led to the black metacinnabar. By heating, we converted the metacinnabar into the red form.
The ancient alchemical sources also include orpiment, realgar, and stibnite to make mercury solid. These procedures were explored for the first time in our laboratory.
Following again the grinding and heating procedure, we obtain the cinnabar. The replication highlighted the fundamental role of the grinding step, which increases the reaction rate.
The synthesis of cinnabar, along with mercury extraction from cinnabar, allowed the ancient alchemists to experiment with circular transformation of matter. This circularity was depicted in the iconic image of the Ouroboros, a dragon eating its own tail. Its red body, indeed, was called the cinnabar of philosopher by ancient and Byzantine practitioners.